Hello mga kamath! Our video today is about regression tests for your thesis and when to do it. Regression tests are used to test cause and effect relationships. They look for the effect of one or more variables on another variable. There are several types of regression tests. For this video, we are going to discuss four. The first one is the simple linear regression. The second one is the multiple linear regression. The third one is the logistic regression. And the fourth one is the multinomial logistic regression. Let's start with the discussion with the simple linear regression. And to be able to illustrate this, I have here several examples. On the research question example, the predictor variable and the outcome variable. This time, I want to emphasize that when you are using a simple linear regression, there is one predictor variable which is a quantitative or continuous. And the outcome variable is also quantitative or continuous as differentiated with t-test or ANOVA. In ANOVA, the dependent variable is continuous, but the predictor variable is categorical or qualitative. Dito sa simple linear, pareho silang numerical. So, yung predictor mo, numerical. Yung outcome mo, numerical din. An example is, what is the effect of income to longevity? Ito yung buhay natin kung gaano ka ng kahabang taon na nabubuhay. Actually, ito yung age. Okay, so ang average annual income would be your predictor variable. Tinitingnan mo kung ano yung relationship nung annual income mo dun sa edad mo. Tingnan natin kung merong relationship siya. Another example is effect ng salary sa happiness. Yung happiness, i-rate mo siya. Kaya siya ay numerical. And then, of course, your monthly salary, numerical din yan. Kasi measured in kung ano man yung currency. If you're in the Philippines, it's measured in pesos. Pag sa US, dollars. Pag sa Canada, Canadian dollars. So, mga ganon. Now, what is the effect of rainfall to soil erosion? The amount of rainfall, ang unit of measure niya ay millimeters. Meron kasing rainfall gauge. If you are a scientist, you know this. And then, yung soil erosion niya in square meters. Bibilangin mo kung gaano kalaki yung area na apektuhan, na nag-erode yung soil. It requires, of course, a lot of research about what is soil erosion, what causes it, how do you determine if the soil actually eroded, and there are several categories of soil erosion. So, all of this sa mga scientific studies. Basically, ang gusto kong i-emphasize dito, you do a simple linear regression if you have only one predictor variable and you want to see its relationship to the outcome variable. Both of them are numerical. Now, let's discuss the assumptions to be able to do a simple linear regression. The first assumption, again, your two variables should be measured at the continuous level. This is already discussed. There needs to be a linear relationship between the two variables. It is a requirement. After the first assumption, you have to test the second one. If you are doing in SPSS, you can do a scatter plot. There are other statistical tools for which you can do a scatter plot. We can test linear relationships from statistical packages. If the relationship displayed on the scatter plot is not linear, here's what you do. You will have to either run a non-linear regression analysis, meaning you cannot do a simple linear regression anymore. You have to do this non-linear regression analysis or polynomial regression. Either that or you transform your data to make it linear. That's what you do. It's a bit complicated. Doing a linear regression or regression analysis is more complicated than doing an ANOVA, a Thesis, a chi-square. That's why regression analysis are usually done during the master's thesis or doctoral thesis because it requires a lot of tests for you to be able to do this. Assumption three is there should be no significant outliers. You should have independence of observations, which you can easily check using Durbin-Watson statistic. So again, you have another test here. Your data needs to show homoscedasticity, which is where the variances along the line of best fit remain similar as you move along the line. So from Durbin-Watson, you have to do another test. And then finally, you need to check the residual errors of the regression line are approximately normally distributed. The assumptions for regression are quite strict. If any of this tests was not complied by your data, you cannot do a linear regression analysis. The next type of linear regression is the multiple linear regression. And to illustrate, I have here another table that gives us research question examples, predictor variables, and the outcome variable. You notice that for predictor variable, we got two quantitative continuous data, and then the outcome variable is also continuous or numerical. So the predictor variable 1 and 2 are both numerical, and the outcome variable is also numerical. Let's check each one. What is the effect of income and minutes of exercise to longevity? This time, as differentiated from the first table, aside from the annual income, you want also to check if annual income and the length of exercise that you do every day or every week for that matter affects your longevity, how long you are living here in this planet. That's if you want to check if the more income you have, the more exercise, the longer you live, or the other way around, something like that. The next example is what is the effect of salary and number of close friends to happiness? Again, monthly salary is measured in the currency. Number of close friends, this is continuous, right? You can either have no friends, one friend, several friends. And the rate of happiness, again, is scored. So all of these are numerical. And then the effect of rainfall and the amount of vegetation to soil erosion. Vegetation is also measured in square meters as well as soil erosion. This time, you want to check if the more rainfall or the more vegetation would produce less or more soil erosion. You want to check its relationship. So the assumptions for this are listed here. Let's check one by one. Your dependent variable should be measured on continuous scale. So it's either interval or ratio. You have two or more independent variables. That's the minimum, two. If you only have one, then you can do the simple linear. Now this time it says here that it can either be a continuous or a categorical. In our example, we have both quantitative or continuous variable as predictors. But our assumption number two, it doesn't limit it into continuous. Your independent variable can either be continuous or categorical. In assumption three, you should have independent observation. Do another test. It was mentioned previously, Durbin-Watson statistic. And then assumption four, there needs to be a linear relationship between the dependent variable and each of your independent variables. In other words, you have to check a linear relationship between predictor 1 and the outcome, and then you have to test it again for predictor 2 and the outcome. So each of them should have a linear relationship with the outcome variable. Otherwise, there's no need for you to do a multiple linear regression because assumption 4 is already not complied with. In continuation with the assumption 4, if the relationship displayed in your scatter plots and partial regression plots are not linear, you will have to run a non-linear regression analysis or transform your data as mentioned previously. And in assumption 5, your data needs to show homoscedasticity, which is where the variances along the line of best fit remain similar as you move along the line. The sixth assumption, your data must not show multicollinearity, which occurs when you have two or more independent variables that are highly correlated with each other. Remember that in assumption 2, you have to check the linearity between predictor and outcome, predictor 1 and outcome, predictor 2 and outcome, but there shouldn't be a collinearity between variable 1 to variable 2. That's what's meant by the assumption 6. It must not show multicollinearity. It says here that you have to detect for multicollinearity through an inspection of correlation coefficients and tolerance VIF values. Okay, and then you have to interpret this so that you can determine whether your data meets or violates this assumption. Aside from Durbin Watson, you do a scatter plot test, you do a homoscedasticity test, and then you do these tolerance VIF values to be able to perform a multiple linear regression. Otherwise, you must do a non-linear regression analysis, as stated here in assumption 4. There is another test required for a multiple linear regression. It's really very complicated. That's why not a lot of people does this. Only, high stat advanced statistical. This is an advanced statistical test. For assumption 7, there should be no significant outliers, high leverage points, or highly influential points. As stated in any other statistical test, outliers are removed. And then finally, you need to check the residual are approximately normally distributed, either from a histogram and a normal PP plot or a normal QQ plot. These are available on several or in all statistical packages. You should know how to do this. There are a lot of tutorials that you can get from YouTube. So, 8 assumptions for multiple linear regression. Now, for logistic regression, sometimes it is referred to as a binomial logistic regression. It predicts the probability that an observation falls into one of two categories of a dichotomous dependent variable. This time, the outcome variable have only two values. Like for example, when you do is there a relationship between the level of your test anxiety, to the number of hours you're present in a lecture, okay, lecture attendance. And then your exam result would be you pass or you fail. Is there a relationship with these two or these three predictors? Okay, so take note. These are the first one. Time or length of exam in minutes or hours. The test anxiety level. The lecture attendance. This time, these are all numerical. And you want to know if all three has a relationship with a dichotomous exam result. This time, we are not looking for the score itself. It's either you just pass or you fail. There are only two. The other example would be the predictors are income. This is numerical. Your age, also numerical, and gender. Gender, male or female, is a categorical. So it's either numerical or categorical predictor. 2, drug use. Are you a drug user? Yes. Or a drug user? The category is no. So there are only two. So user or non-drug user. with three different predictors. And you do a binomial logistic regression simply because the outcome variable are only two categories. Yun yung emphasis dito. Yung outcome mo, dalawa lang. So, pag sumasagot ng yes, no, binomial logistic regression yung gagamitin mo. Tapos yung predictor mo, pwedeng dalawa o kaya ay tatlo. These are the assumptions for logistic regression. The first one, your dependent variable should be measured on a dichotomous scale. Okay. Examples on dichotomous are gender, male, female. Kung may heart disease, yes or no. Personality type, kung introvert, extrovert. Body composition, dalawa lang dapat ha. Pag sinabing logistic regression, yung outcome mo, laging dalawa lang yung category. Obese or not obese. Hindi pwede yung sa BMI na merong underweight, obese, overweight, etc. Dalawa lang dapat dito. And then yung assumption 2, you have one or more independent variable. Pwedeng isa lang, pwedeng madami. And then, pwede siyang continuous or categorical. Basta't yung iyong dependent, importante to, yung dependent mo, dalawa lang lagi. Ito kahit ilan. And then you should have independence of observation. Again, syempre, walang kinalaman sa isa't isa. There needs to be a linear relationship between any continuous independent variables and the logit transformation of the dependent. So, gagawin mo siyang logit. Ito-transform mo siya. And then, iti-check mo siya using the box-Tidwell procedure to test for linearity. So, yan, may bago na naman. No? Bagong test na naman. That's why itong mga regression para to sa mga advanced stat. Now, for the multinomial logistic regression naman, madami ka namang outcomes. Pero, mapapansin mo ang kaibahan nito dun sa mga t-test ANOVA, yung outcomes niya categorical. Yung mga iba't ibang klase ng t-test at saka yung iba't ibang klase ng ANOVA, yung outcome niya puro numerical. Ito naman puro categorical yung outcomes niya. Tapos yung kanyang mga predictor, it doesn't matter kung categorical or numerical siya. Pumapayag siya na ganun. Pero madami siyang mga test kang gagawin para mo magawa yung or makuha mo yung value ng multinomial logistic regression. Kasi kailangan mag-comply siya sa lahat ng assumptions eh. Example natin, di ba? So, we have 3 predictors. Yung place of origin mo, pwedeng pangalan ng city, o ng state, sa atin province, or sa country kung international yung study mo. Kasi nga, di ba, pang mga pang-doktor na itong mga ganitong klaseng test. And then yung age, ito categorical to. Ito, numerical. Tapos, sex, female or male categorical din. Tapos, titingnan mo kung anong gusto niyang inumin, kung kape, tsaa, soft drinks o kaya tubig. Itong klase kasi na to, ginagawa to sa mga airlines kaya ito yung yun yung mga predictor niya at saka yung mga outcomes niya. Kaya ganyan. Parang gusto nilang i-predict pagka kung saan ang galing na country yung eroplano, yun yung i-stack nila doon sa, 'di ba, nagse-serve sila ng mga inumin sa airplane. That's why parang tinitingnan nila ano ba dapat mas madami bang kape or tsaa or baka wala namang alam mo na yung mga tea drinkers kasi pagka ganon. So, yun yung nilalagay nila dun. Kasi sa aeroplano, di mo naman pwedeng ilagay sobrang daming stocks. Di naman siya parang supermarket na pupunuin mo ng mga iba't ibang stocks. So, parang gumagawa lang sila ng prediction. Or parang sabihin na lang natin na yung mga passengers hindi ma-out of stock yung pag naghumingi sila ng halimbawa gusto nila ng soft drink. Hindi mo sasabihin na I'm sorry, wala na. Kailangan maayos yung stockings mo doon ng mga pagsa-stock mo ng mga supplies sa eroplano para mas okay. Now, yung mga predictions niya or yung assumptions niya ganito. Una, yung dependent variable mo, nominal. Okay, nominal. Hindi basta yung ordinal. Bawal dito yung ordinal. Nominal lang. Okay? Tapos yung assumption 2, you have one or more independent variables that are continuous, ordinal, or nominal. Pwede din yung dichotomous yung may yes or no. Okay din siya na predictor. And then, yung ordinal independent variable mo, wag mo siya i-treat na ordinal. Ilalagay mo siya kasi sa mga statistical packages, ilalagyan mo siya ng category. So, wag mo siyang gawing ordinal, gawin mo lang siyang categorical o kaya continuous. Continuous na kasi ordinal nga eh. Di continuous mo na lang imbes na depende dun sa statistical package mo. And then sa assumption 3, you should have independent of observations. And then no multicollinearity. And then there needs to be a linear relationship between any continuous independent variables and the logic transformation of the dependent. So gagawa ka na naman ng test. And then no significant outliers. So bali yan yung mga assumptions that you need to satisfy. Your data needs to satisfy to be able to perform logistic regressions. Quite complicated, di ba? Kaya pang siya pang advanced statistics. So next time, I would discuss yung correlation naman para makita nyo kung karapat-dapat para sa inyo. Yung mga BSI don't usually recommend this type of kasi hindi naman to dinidiscuss sa elementary statistics na pang college. So this is not for you. Pang mas matataas na level. Okay? So for now, ito muna and watch out for para dun sa correlation. Thank you very much for watching and God bless.